Welcome to the Explainer. So, today we're diving into a breakthrough that could literally let us put smart tech, well, pretty much anywhere, without ever having to change a battery. It's a huge step towards a world that's not just connected, but also sustainable.
All right, so let's just jump right in. Take a look at the setup here. What you're seeing is a tiny computer that's running entirely on energy it's harvesting from its surroundings. In this case, from radio waves and a little solar panel. And look, this isn't some far-off sci-fi concept. This is the real deal. It's the foundation for a whole revolution in smart technology.
So, what's the big picture? The dream, really. It's a future filled with trillions of these little autonomous sensors peppered everywhere, monitoring our farms, our cities, our bridges, making everything way more efficient, and get this, all without the huge environmental headache and cost of batteries.
But of course, there's a catch. A big one, actually, that's been a roadblock for years. To make these sensors truly smart, they need to be able to run artificial intelligence right there on the device. And it all boils down to one simple, fundamental problem: power.
You see, the problem is, the AI we're all used to, the stuff running on your phone, in the cloud, it's incredibly power hungry. It needs heavy-duty math and powerful processors to do its thing, which is, the exact opposite of what these tiny energy-sipping sensors can offer.
And when I say the difference is big, I mean it is staggering. So on the left, you've got your typical microcontroller that modern AI is built for, and then on the right, that's our batteryless sensor. We're talking a tiny, tiny fraction of the processing speed and something like less than 2% of the memory. It's not just a different ballpark, it's a completely different sport.
Okay, so because these devices have basically no resources, they operate in this really weird way called intermittent computing. Basically, the device wakes up, does a tiny bit of work for just a few milliseconds, until, poof, its little energy reserve is gone, and then it just shuts down completely to recharge. This constant cycle of power on, power off, it's an absolute nightmare if you're trying to run something complex like a traditional AI model.
So here's the bottom line. Trying to run our current deep neural networks on these things, it's not going to happen. It really is like trying to power a supercomputer with a watch battery. The model's too big, it's too slow, and it's way, way too hungry for the little sips of power it can get. It's a total non-starter.
Okay, so if the old way is a dead end, we need a totally new approach, right? And that's exactly what researchers did. They turned to a completely different kind of AI, one that doesn't think with all that complex math, but with simple, super efficient logic.
And this image here, it just perfectly captures that core idea. We're shifting away from those heavy, non-stop calculations you see in a neural network to something built on simple, distinct logical steps. It's all about being streamlined and efficient from the ground up.
So, what is this thing? It's called a T-Cetlin machine, and with this, you can pretty much forget all that complex floating point math. Instead, it works by building thousands of simple if-then rules based on the data it sees. It literally learns to spot patterns by creating this web of pure logic. And because of that, it's naturally lightweight, just perfect for these tiny, low-power devices.
Okay, so how does it actually make a decision? Well, instead of crunching a bunch of numbers, it's more like a democracy. It's a voting system. The input data gets turned into simple true-false statements. Then thousands of these little logical rules, they're called clauses, each get to cast a vote. And the final prediction, it's just the outcome that gets the most votes. Super simple, right? It's all about finding a pattern by reaching a consensus.
But even this super efficient model wasn't quite enough for the batteryless world. It needed to be pushed to the absolute limit. And that's what led to the creation of this new framework called LightTM, which was designed to make these logic-based models insanely small and incredibly fast.
So, first off, LightTM uses some really clever tricks to compress the AI model after it's been trained. It finds all the repetitive parts in the logic and basically squishes the whole thing down, shrinking its memory footprint by up to a whopping 99%.
And it's not just about saving space, it's about saving time, too. The framework is smart enough to find computational shortcuts in the logic. It figures out which rules it can just skip for a particular input, which, as you can imagine, speeds things up a lot, by as much as 13.5 times.
And just to give you a sense of what that compression looks like, check this out. The bar on the left, that's your standard Tetlin machine model. And the tiny little bar on the right, that's the same model after the LightTM optimization. We're not talking about a small tweak here. This is a total game changer. It makes the model small enough to fit on pretty much the tiniest, most resource-strapped chips you can find.
But honestly, here's the part that is just revolutionary. The system is adaptive. And this is really the key takeaway. So let's say it's a cloudy day, not much solar power coming in. The sensor actually knows this and can automatically switch to a simpler, faster version of the AI model to save energy. Then when the sun comes out and there's more power to spare, it scales right back up to its full complex self. How cool is that?
So let's bring this all back home. What does a breakthrough like this actually mean for the real world? I mean, what can we do with this kind of adaptive, batteryless intelligence?
Well, it basically opens the door to a whole new class of set-it-and-forget-it smart devices. Think about it. Soil sensors you can just leave in a field for decades, wildlife trackers that monitor animals without ever needing to be recaptured for a battery change, or maybe wearable health monitors that you literally never have to take off to charge. We're talking about intelligence that you can just deploy anywhere and trust it to work on its own forever.
So the big takeaway here is that we are right on the edge of something huge. We're on the cusp of embedding intelligence into the world all around us in a way that's both powerful and sustainable. By completely rethinking AI from the ground up, making it based on logic, making it aware of its own energy supply, we're finally starting to tear down one of the biggest barriers that's been holding back a truly smarter planet.
And that really leaves us with one final, pretty exciting thought. For decades, our imagination has been tethered to the power cord, or the battery life. We could only put computers where we could power them. But now that that fundamental barrier is starting to crumble, what's next? What incredible new things are we going to create?